In this project, I built a machine learning model to predict customer churn using the telco customer churn dataset. So in this cell, I import the main libraries used for data processing, machine learning, and model explainability. So here I load the dataset. Each row represents a customer, and the dataset includes demographic information, service usage, contract type, payment method, and billing information. And the dataset was initially loaded as a single column due to the formatting issues, as you can see here. And so I split the column by commas and assigned the correct column names to reconstruct the dataset structure. So in this step, I clean the data set and convert numerical variables such as potential monthly charges and the total charges into numerical format. I also convert the churn variables into binary values. Uh, where one represents churn. So after cleaning the data set contains like 7,032 customers and 21 variables. The true distribution shows that about 26.6% of the customers churned, which indicates some class imbalance. So here I just checked the dataset structure to confirm that the variables are correctly formatted. So in this step, I separate the data set into futures and the target variables. The target variable is true, and all other variables are used as predictor. Since the data set includes both categorical and numerical variables, I applied pre-processing. Numerical variables use median imputation, and the categorical variables are encoded using one-hot encoding. And so the data set is split into training and testing set using an 80-20 split while preserving the churn distribution. So I use a random forest classifier because it performs well for structured tabular data sets and provides future importance for interpretability. And the model achieved uh, accuracy of 0.749 and a precision of 0.519, recall of 0.77 point 8 and F1 score of 0.622 and AUC of 0.834. So relatively high recall means the model successfully identifies many customers who are likely to churn, which is useful for customer retention strategies. So the confusion metric shows 763 true negatives and 291 true positives, along with 270 false positives and 83 false negatives. This means the model tends to flag more potential churn cases, which increases recall, but it also produces some false alarms. To understand the model behavior, I exam future importance from a random forest model. And here to understand the most important future include month-to-month contracts, tension and total charges, 2-year contracts, and so on. These results suggest that customers with shorter contracts and weaker service support are more likely to churn. So, this visualization highlights the most uh, influential variables in predicting churn. And here to further improve uh, inter interpretability, I use sharp values to analyze how different future influence churn predictions. The sharp summary plot confirms that contract type, potential internet service type, and customer charges have the strongest influence on the churn risk. So I also performed a fairness check across demographic groups. For gender, the predicted churn rates are very similar, which suggests the model treats male and female customers similarly. However, the predicted churn rate for senior citizens is higher than for non-senior customers. The difference should be monitored carefully to ensure the model does not introduce unintentional bias. So overall, this project demonstrates how machine learning can be used to predict customer churn while maintaining model interpretability and fairness awareness. The model achieves reasonable predictive performance and provides useful insights into the key factors that influence customer churn. And thank you for your listening.